Hello everyone. Today we are diving into the world of industrial process, automation, and control. Key concepts that keep modern industries running smoothly. Let's start with the basics. What is a process? If you look it up in the dictionary, a process is simply a series of actions carried out in a specific order to achieve a predefined result. Think of it like following a recipe to bake a cake. You have steps, and each steps builds towards that final delicious outcome. In manufacturing, this means taking raw materials and turning them into a finished products through physical or chemical procedures. It's a systematic economic activity, whether it's making cars, processing foods, or refining chemicals. Now, processors are not just limited to manufacturing, they can be anything from agriculture and aviation to banking, education, healthcare, retail, transportation. But in industry, some of the most popular processes include chemical, petrochemical, fertilizer, power generation, metallurgical, food processing, pharmaceuticals, and more. The big goal here, the productivity with assured quality. That's why industries are increasingly turning to automation technique to boost output while maintaining the top-notch quality. And now let's move to the automation part. So, what is automation and control? Now the word automation comes from the Greek roots. Auto meaning self and matters means moving. Put them together and you get a system that moves by itself. In other words, automation is a set of technologies that lets machines and systems operate with little to no human intervention, and it does so better than if we were doing it manually. Imagine a factory where robots are assembling parts without someone constantly pushing buttons. That automation at work. But to make sure an industrial process runs the way we want, we need control at every step. Control is like the brain behind the operation. It's a set of policies and techniques that keep operational parameters and sequences on track by providing the right input signals. For example, if you are controlling the temperature of in a chemical reactor, the control system ensures it stays at the set point, not too hot or not too cold. Here's something important to grasp. An automation system might include a control system, but not every control system is a part of automation. The control system's main job is to make sure the output matches the desired value or set point. Automation, on the other hand, can do more. It might set those points, monitor performance, handle plant startups or shutdowns, schedule jobs and equipment, and so on. Control engineering is a cornerstone of automation, making all these tasks physically possible. So, why do you think control is so critical? Well, a controller's job is to measure a process variable like temperature or pressure or level or flow, compare it to the set value, and take action to keep the thing steady. Without control, process variables would drift, and that could mean wasted resources, poor product quality, safety risks, or environmental damage. That's why controllers are vital for economy, reproducibility, quality, safety, and protecting the environment. Back in the day, we had basic pneumatic PID controllers, proportional, integral, and derivative, but now software based digital PID controllers are the norm with added features like data acquisition, sequencing, recipe scheduling, and aligning. So why we need automation and how it is evolved? Let's step back to the think about why automation become necessary. In the early days, process plants were like isolated islands. Each unit operated independently, and coordinating them was labor intensive and slow. But today, auto manufacturing and process industries aim to deliver high quality product quickly, at lower cost and with minimal downtime. To maximize the profit, we need to produce quality products with a large volume in fast and cheaply. There are four key parameters to consider: flexibility, quality control, inventory control, and speed. Flexibility means being able to configure assembly lines and redesign facilities to stay competitive and improve quality. Quality control today demands coordinated data collection and analysis to ensure every product meets standards. Inventory control, like just in time strategies, cuts in overhead by reducing warehousing needs, and speed, customers operate and just in time too. If you don't deliver on time, they lose production time and you lose customers. So, how do we achieve this? With well designed and automated hardware, softwares, and systems running on local area networks on the factory floor. Automation has evolved from basic hydraulic and pneumatic systems to today's robotic control systems. The goal that is the boost productivity and slash labor costs. Since its starts, industrial automation has taken over tasks that were once manual, leading to the better efficiency, higher quality products, and lower production costs. In the 1970s, we saw the rise of enterprise resource planning or ERP from the companies like SAP. ERP standardized business practices but was not customizable. So companies added their own code which created IT headaches. Then in mid 90s, 1980s, what digital workforce evolved into business process management or BPM. Thanks to the IBM system to system messaging, BPM is customizable, API driven, and focuses on reshaping the processes for maximum efficiency. Most recently, in 2012, robotic process automation or RPA came into the scene. RPA uses software robots to handle repetitive tasks. Letting the employees focus on higher priority work. It's user friendly, platform independent, and requires no programming perfect for non-technical user to solve their automation challenges. The role of automation in the process industry. So what does the automation actually do for the process industries? It plays a huge role. For example, an automated market study can help to decide the best time to buy raw materials, and automated feedback surveys can guide product redesigns. The benefits are clear: reduce production cost, quicker part of cycle time, improve quality and reliability, better floor place use, less waste, and staying competitive by hitting high throughout while keeping the cost and schedules in check. Automation ensures a quick return on investment, and robots work longer and faster, increasing production rates while maintaining the precision. Imagine a robot assembling parts with the same accuracy every time. That's repeatability. And because robots are so precise, they uses less raw material, cutting waste and cost. Plus, automating parts of a production line free up space for other operation, making the process flow more efficient. In short, automation keeps you ahead of the game. So now let's talk about the architecture of the industrial automation networks. Finally, let's look at how the systems are structured. Modern industrial automation uses a five-layered communication hierarchy. Think of it like a pyramid, each layer building on the one below. So here how it is works. Field level, that is the ground floor. Sensors, actuators, switches in the tanks, vessels, and pipeline. Sensors measures the things like temperature, pressure, or flow, and send signals to the next level. Actuators like valves or pumps act on those signals to control the process. IO level, this layer gathers all the inputs and output signals. It directs sensors data to controllers and sends controller demands to the actuators. Control level, here the signals from the sensors are processed. Command for actuators are generated based on desired output. This is where the PLCs, distributed control systems, and SCADA systems live. HMI level, the human machine interface level shows operators what's happening throughout the organized displays. Tools like data acquisition, recipe management, and maintenance schedules help manage the processes. Operators can see the whole plant schematically, taking corrective actions, and handle alarms, logs, and reports. Enterprise level, that is the topmost level. At the top, all information flows into the management information system. There is where the big decisions happens: ordering, production, scheduling, billing, shipping, future planning. All of this driven by the softwares. So this is the overall architecture, 5 layer structure, which are seen here. That's the end of this lecture. Thank you.